Welcome everybody and thank you. My name is Chris Neitzold. I'm Senior Hardware Engineer here at Scale Computing. I manage all things hardware on the product team. And we're going to go ahead and go through some of the new things that we're looking at in the upcoming year, as well as just covering some of the details about how we manage the hardware and how we deliver the product here. So starting off, I wanted to touch on really what goes into putting together a platform and then supporting that platform. So we had talked a little bit last year about kind of the nuts and bolts of what goes into a platform, but really at a high level, wanted to discuss looking at the inception of a brand new platform. There's a lot of considerations that may not be totally obvious, and some of them you'd probably be very familiar with. Things like lifecycle cadence, and what that means is where are we jumping in within a given product's lifecycle. If you look right now, we have the Intel Sapphire Rapids platforms that are out in the wild, but now they're starting to be supplanted by the Emerald Rapids platform, which is largely identical, except that it has new CPUs, it has new memory configuration options. We just need to be cognizant of where we're jumping in on that particular life cycle. That'll often dictate what it is that we choose to do and when we're going to support a platform. Of course, there's the supply chain health, and then going along with that, the supply chain security. So knowing that we can always bring in the product that we need to deliver these platforms and also know where it's coming from with some level of certainty. Along the lines of that, firmware control. And this can be as rote as just making sure that we know what firmware goes on every machine, but also making sure that that firmware is secure. It kind of all ties into that supply chain security. We're also looking at component qualification. Of course, when we order these systems, if they're coming from a Lenovo or a Dell, we know that they've done a fair amount of product qualification, but we also need to know that our product and our software is going to mesh well with that particular product. And along those same lines, performance fitness. It's one thing to be compatible, but we need to make sure that it meets specific criteria. And that the performance may not always just be the speeds and feeds, but also making sure that we have the necessary tooling available so that we can do predictive failure, self-healing, and really understand if and when something does go wrong, we can identify it quickly and work to resolve it quickly because we have all of the instrumentation that we need. Another item is that component endurance. We need to make sure that when you're purchasing a node and putting it out in the field, not only does the hardware itself need to be reliable, but it also needs to be fit for that particular task. You don't want to undersize the SSDs, for example, and find that you've exhausted the endurance, and then you have an RMA denied, for example. And then, of course, application fitness. And this, again, comes down to making sure that the types of applications and workloads that are going to be running on the HyperCore platform, they perform exactly as we would expect. Beyond that initial inception, there's also a lot of ongoing work that goes on for every single one of the platforms. Component qualification comes up again. Reason being, over time, various vendors that comprise all of the pieces within a system, they're going to go through their own product life cycles. They may revise the parts, they may need to substitute something out, or they may have just made improvements. And we need to test each one of those and make sure that they're going to be a good fit for the platform. Additionally, the firmware testing, as new releases of firmware come out, we want to adopt those often rapidly because in many cases they'll contain security fixes or just platform improvements that we want to take advantage of. As those new firmwares roll out and the new components roll out, we also need to continue with ongoing driver support, making sure that the underlying kernel for the hypervisor has the necessary components to speak to each one of those devices and do it correctly and predictably. And of course, along the way, we're looking to optimize. We're looking to improve the self-healing. We also need to take a look at the extended support, meaning, when you have a platform that's perhaps 3, 5, even 7 years old, and we're still providing hardware support for that particular platform, we need to be able to procure those components. And while all of this is going on, we're doing a lot of support kind of trend tracking. We're making sure that if we see, a specific type of failure, we're going to measure that against previous failures, and we're going to see, is there a trend developing, or is it something that we need to investigate further? And of course, interoperability, and that's really going to speak to the next slide. So interoperability is, of course, a core tenet of the platform. We want to make sure that if you jump onto a particular platform at any moment in time, that moving forward, when you need to add new nodes and expand that cluster, you can do so without much consideration for the generation of product that you're purchasing. So even in this example, starting with an HE150, maybe a couple of years go by and now you need to expand that cluster. Well, the HE151 is available. May as well take advantage of that. Newer CPU, better performance, not to mention the dual NICs. That's nice. And then moving forward again to modern day, perhaps adding an HE153 or an HE153S to match with the slim profile of the original HE150. And this is all going on for myriad platforms. Now, I don't expect anybody to take a look at this particular slide and make heads or tails of it, but this just gives you an idea of the timeline over just the past half a decade of platform launches, each one of these having multiple variants, really just showing the progression over time, along with the Intel release cadence right below that. So with that, I think we can jump into the roadmap and a somewhat equally dense slide showing the actual release cadence for all of our products, and really starting with the top. You know, we've recently released the HE153. We'll get into details about that, but looking far off into the future, really about a year from now, we should be looking at probably the next generation of that product, and there will be some overlap. You'll note that on the HE153, I did not put an end of sale at the end of that line, and that'll be true for a couple of the platforms. Really, there will be overlap. We don't have a hard end of sale date for that one. We want to make sure that there's plenty of time to transition, and really there's no hurry on that. If you want to take advantage of the newer technology at that time, that'll be available to you. Moving to our HE500, the HE501 and 551 platforms have been a good success for us, and we're looking forward to the next generation of that likely launching into Q3 of this year. Our HE1000 series, currently the 1300 and 1350, we'll be looking to revise that coming up here probably in the fourth quarter. That's still a bit TBD, but that'll be on the Emerald Rapids platform. And then going down the line, our 1450D and 5450D, both of those platforms are currently available, and they're also available via Lenovo On Demand. And those will be available for the foreseeable future, though they may receive a mid-cycle upgrade with some additional CPU SKUs. And right around the corner, we have our follow-on to the 3350F and DF, are all NVMe platforms, 3450F and DF. Those will be launching here very shortly on the Emerald Rapids platform, taking advantage of all the latest technology there, as well as the latest NVMe. And of course, all of the systems that I've mentioned so far within that core portfolio, they'll all be equipped with either the 10 gig base T or the 10 or 25 gig SFP28. And that's just going to be the standard going forward for really any platform that we have coming up. In addition, I'm sure that for anybody out there using the HC5200, we do have a 5400 coming here pretty soon, likely around Q3, and that'll fill in that space for just pure capacity play. And then something a bit more exciting down there at the bottom, which we'll discuss in a future slide. So just reviewing, taking a look at our HE153S and HE153, I wanted to make sure that this was really put front and center, because I know that we had launched the HE150, the original, as a slim product, and then we moved to that taller product with the dual NICs for the subsequent versions. Well, with this generation, we've made sure that we have a slim version available. It can be outfit in exactly the same way as the tall version, the standard HE153. The difference being, of course, that it only has the one network interface, but it does have the smaller stature and fits nicely within a 1U rack space. Now, rather than jumping over to the HE500, we're going to make a quick pit stop at a new entrant, the HE250. This has been a platform that we have been thinking about for a very long time, but just hadn't really found the right hardware to launch it on. But we believe we found that, and the HE250 fills this role, fills this gap right in between the HE150 series and the HE500 series. Rather than being forced to have a rack mount system, this is a more small form factor system that can be deployed just about anywhere. It is larger than the NUC form factor, but it also packs quite a bit more technology under the hood. This really is the new standard in our performance small form factor. If you can afford the extra space and you need the extras that this brings, it's a very unique platform. It does have remote management via the vPro AMT solution. Still a compact form factor, and you can see in the kind of rack illustration below that you could fit up to 4 nodes into a 3U rack. So you can think of them almost as a half 1U type of solution. So an interesting note about the CPU, it does have ample cooling and it is quite powerful, but interestingly, it's roughly the same CPU that you'll find in our HE153, the i7 variant. However, this particular version has a 45 watt TDP and it can peak up to 115 watts. What this equates to is about a 40 to 60% increase in performance over that HE153. So for very demanding applications, this can be a great solution. And then additionally, it can carry 3 NVMe drives, and those will be available in 1 terabyte, 2 terabyte, 4 terabyte, and up to 8 terabyte each. So you're looking at a raw footprint of 24 terabytes within that half 1U space. Another highlight of this platform is the networking. Now we're going to be setting these up with Edge Fabric all around, so really regardless of how you connect this device, you'll be able to do so backplane over VLAN very simply to get it deployed quickly. But for a faster backplane, or to make sure that you have the maximum amount of throughput, you do have 10 gig SFP Plus provided by an Intel X710. So excellent networking options. And moving on to the HE500. So our HE500 line has a little bit of something for everyone. We've got the all-spinner version, we have our tiered version, and we have our all-flash version. And like I said, those will be revised here coming up probably about Q3, but for the time being, those are still here. Our HE1000, or really 1300 and 1350, those are on our Ice Lake platform, and they're pretty substantial upgrade from the previous 1200 and 1250 platforms. And like I said, the networking has been unified on that 1025 and then 10 gig base T. And our recently launched 1450D and 5450D using Sapphire Rapids platform, very well equipped. And now the flash tier is provided by NVMe. And you can get those NVMe drives up to 15.36 terabyte per drive. And then on the spinner side, you have up to 20 terabytes. When the 24 terabyte, we were actually skipping the 22 terabyte, but when the 24 terabyte drives are available and kind of come into a reasonable pricing level, we will be adopting those. The 3450F and 3450DF, these are on the Emerald Rapids platform as discussed before. And this is going to be the same 4 drive and 10 drive, all NVMe configurations as a follow-on to the 3350F and DF. Once again, we've kind of done the unified networking, and on these, without a doubt, the fastest systems that we have ever released. Up next, we have the 5400. This is still slated probably around Q3, like I said, though it will be going to pre-sale here shortly, and this is our capacity play. It's going to look very similar to the previous generation, but you will notice that it has up to 20 terabytes per disk, up to 12 disks, as well as that unified networking. And this is on the Sapphire Rapids platform. We've tried to make a processor selection here that balances really cost versus the level of performance that you get, and something that's a little bit more tuned to specifically the all-spinner setup. Touching on our video surveillance platform for a moment, we currently have the 5250D-V, which has been successfully deployed at a number of sites, running 24/7, 365 operations for video surveillance recording. We're going to do a follow-on to that. Of course, it'll be the 5450D-V. The actual specs are still being nailed down. We don't have a release date yet, but know that it is on our radar. And the one thing that we can share is, of course, the unified networking approach. That will be the same as it is on the other platforms of this generation. And finally, we'll touch on the new GPU platform. This one has been a long time coming. We understand that our current GPU offerings are getting a little bit long in the tooth now, and so it is time for a change. What we are waiting for with this one is a solution that could support SR-IOV right out of the gate, because we see that as really the gateway to opening up a lot more functionality for GPU allocation to VMs, but in a more universal way rather than using only proprietary tools. So this system will be using the latest and greatest of Emerald Rapids chips. It'll be equipped with a single NVIDIA L4. We chose that GPU specifically to make sure that we're keeping this system very modular It can be an add-on to an existing cluster, or it can be a standalone, but really you're not going to be on the hook for purchasing 5 GPUs in each node. This is equipped very much the same as a 3450F, just with the GPU. We want to make sure that you have the same familiar virtual GPU allocation workflow, but we want to make sure that the drivers specifically, whether it's for the host itself, the actual platform, or the guests, it's going to be an easier experience. There's going to be kind of more of a self-serve approach so that you don't have to reach out to support in order to get that upgraded. Finally, as a long time coming, UEFI guest support, and that will be backported to the existing GPU platforms as well. So if that's something that you're currently using today, UEFI guest support will be enabled. Fully functional and reliable live migration is going to be a focus on this new platform, and that is something we're going to be looking to backport as well to previous platforms, though we may run into some snags with the vendor who supplies the GPUs. We'll certainly keep everybody updated on that one. And this platform is targeted for a Q3 launch of this year. I believe we'll be opening these up for pre-sale coming up shortly. Now, earlier I mentioned SRIOV, a really single root I/O virtualization. And the reason that I mention it, it's usually something that sits under the hood. It's not something that we expect any of you to think about, but its adoption enables us to really be more scalable and adaptable. We see that there are newer entrants into the GPU market, for example, but not just GPUs. There's also the DPUs or NPUs, whether they're data processing unit or the network processing unit. All of these things are on our radar, and in a virtualization context, we need a way to subdivide those resources and make sure that you can allocate them as you need to specific workloads. Single root I/O virtualization is a method for doing that, where the interface will always be the same from your perspective and actually from our perspective on the back end. And that's going to allow us to step outside of just using a single vendor solution and really only in the context of GPUs. Now, of course, it'll be used for the context of GPUs right away, but this will allow us to expand the scope and really have more items that we can virtualize directly. And with that, I thank you for spending time going through some of these hardware items. If you have any questions, of course, reach out to anyone, reach out to your sales team or anyone from the product team here at Scale Computing. We appreciate it, and we hope you enjoy Platform 2024. Thank you.